Welcome back to Cosmic Galaxy. In this video, we're discussing how was the universe created. Make sure to like the video, subscribe to the channel, and hit the bell icon. We're aware that our universe is expanding. That means the universe is expanding with each passing day. It also implies that our universe was once much smaller than it is now. If you rewind the tape far enough, physics suggests that our universe was once an infinitely tiny, infinitely dense point, a singularity. Most physicists believe this point expanded during the Big Bang, but because all known physics fails in the extreme conditions that prevailed in our universe's infancy, it's difficult to say with certainty what happened in the universe's earliest moments. Going back in time, for most of the universe's history, it was dotted with similar celestial objects as it is now. They were just close together. For example, when our universe was just less than 380,000 years old, its volume was about 1,000,000 times smaller than it is now, and its average temperature was around 10,000 kelvins. It was a plasma, a state of matter in which atoms are ripped apart into protons, neutrons, and electrons, because it was so hot and dense. However, because plasmas are encountered in many other situations in space and on Earth, we have a good understanding of how they work. However, the more we go back in time, the more complicated the physics becomes. When the universe was only a few dozen minutes old, it was a tumultuous soup of protons, neutrons, and electrons governed by the same physics that we use to understand nuclear bombs and nuclear reactors. However, if we go back even further, things become very murky. We have no physics theory that can cope with the insanely high temperatures and pressures the universe experienced when it was less than a second old, and when we try to make sense of it, all of our physics theories fail. And we have no idea how particles, forces, and fields behave in those conditions. Birthing the singularity. Physicists can track the expansion of the universe using Einstein's general theory of relativity, which connects the universe's content to its history of expansion. However, Einstein's theory has a fatal flaw. If we follow general relativity to its logical conclusion, our entire universe was once crammed into a single, infinitely dense point. This is referred to as the Big Bang singularity. The singularity is frequently framed as the beginning of the universe, but it is not. Mathematically, the Big Bang singularity does not indicate that the universe began there. Instead, it indicates that general relativity has failed and has lost its predictive and explanatory power. Physicists have long recognized that general relativity is flawed. It cannot explain gravity at high energies or at small scales, which is referred to as quantum gravity. In other words, new physics is required to fully comprehend the universe's early moments. A question for the ages. Unfortunately, such physics does not currently exist. String theory and loop quantum gravity are two candidates for quantum gravity, but neither has been fully developed, let alone tested. But if either of those theories is correct, it can tell us a lot about the early universe. The singularity in loop quantum gravity is replaced by a finite-sized chunk of space-time. Meanwhile, according to string theory, our universe evolved from a landscape of possible universes. It's also possible that our Big Bang is just one of an infinite number of universes that multiply indefinitely in a multiverse. Only further advances in theoretical physics will be able to sort through the haziness of these potential ideas. However, there is another issue. We may never know what caused the Big Bang. Even our concepts of time and space break down in the early stages. Normal, everyday concepts like beginning and before may not even make sense at such extreme scales. Thank you for watching the video.